Good evening. My name is Trevor Robbins, University of Cambridge. It's a delight to see such a full audience here. Could you please turn off your mobile phones before we get going? Please turn off your mobile phones. So this event is being webcast live, and it has been recorded for the archives of the Royal Society. Now, by way of background, a few words about the Rosalind Franklin Award and Lecture. This is awarded annually to promote women in science, technology, engineering and mathematics, the STEM subjects, and it is given to someone who's made an outstanding contribution in one of those areas. The recipient of the award is expected, as part of their project, to implement some way of promoting women in STEM subjects by means of a project. The award is supported by the Department of Business, Innovation and Skills. So the winner of this year's award is Francesca Happé. She has made a proposal which will implement promotion of women in science through a project which will instruct young children about the role of women in science through a series of small books called My Mum's a Scientist. Francesca has been awarded the Rosalind Franklin Award also because of her scientific excellence and her general suitability for this important role. Francesca is the Professor of Cognitive Neuroscience at the Institute of Psychiatry, King's College London. She was a graduate at Oxford University and did her PhD at University College. She works on autism spectrum disorders and brings together a number of techniques and conceptual approaches to this important problem. She works with cognitive methods and theory, with functional brain imaging, also the study of patients with acquired brain disorders or lesions, and more recently, behavioural genetics. She is the author of many distinguished scientific works and papers in this area, and has also produced a book for the general public on autism. She has several other awards and commendations. She's always had an important connection, as it were, with public engagement, I think it's fair to say. So she was a Royal Institution New Century lecturer early in the 2000s. She's been involved in many documentary programs on television and has been the subject of one herself for Channel 4, describing her work. She has been awarded the British Psychological Society's Spearman Medal for outstanding research, and also a prize from King's College for supervisory excellence as a graduate PhD supervisor. And last and not least, she has been a prize winner of the Experimental Psychology Society. So, ladies and gentlemen, I give you Francesca Happé and her lecture, When Will We Understand Autism Spectrum Disorders? Thank you.
Thank you very much, Trevor. And thank you all for coming. And what a pleasure and what a privilege to be given this award and to have this chance to tell you about some of our research. I want to talk about autism, and I want to talk about what we do know about autism spectrum conditions, why we don't know more, and suggest a few pointers or signposts that might help us on our way. One thing we know is that autism is headline news. Autism is always in the media, and there are many myths and many claims of cures, many claims that we found the genes for autism, and all of these, of course, are false. But autism is important, and autism is certainly not rare. We know that around 1 in 100 individuals, boys, girls, men, women, have autism spectrum conditions. That includes autism, Asperger's syndrome, atypical autism. And that amounts to around 600,000 people in the UK alone who have an autism spectrum disorder. And of course, many more people who are affected by an autism spectrum disorder because they live or work or care for or love people who have autism. Autism is a neurodevelopmental condition. We know that autism isn't caused by refrigerated parenting. We know that there's something different in the brain, something different, usually, maybe always, in the genes. But we don't know what part of the brain is really affected. One of the more promising avenues is that there's brain overgrowth in the first 4 years of life in at least some individuals with autism. But almost every area of the brain has been highlighted at one time or another as being the lesion site in autism. And again, that's obviously wrong. We know that autism is highly heritable and that genetic factors are incredibly important in autism. But we don't know which genes. We know that many genes, but we don't know how the genes act. We know that there's probably an important distinction between de novo cases, cases where a mutation, a change in the DNA arises in just the individual with autism and other family members are unaffected, and familial cases where traits and subclinical signs can be seen in other family members, and other family members share some or all of the genes that seem to be contributing. But we don't know what causes autism. Because there's no biological marker, autism is still diagnosed behaviorally by the presence of impairments in social interaction, in communication, and the presence of repetitive and restricted interests and activities, and all of these being present by the age of 3 years. The range of manifestations is enormous, however, from the child, the toddler who is silent, aloof, spends hours spinning the wheels on their toy cars, to the adult who is socially very interested and wants to make friends but is socially inappropriate, whose special interest is a well-developed knowledge of astronomy and whose language has developed to the point that they love nothing better than to monologue on their own special interest, much as I'm doing now. So the manifestations of autism are extremely wide-ranging, and therefore it's not surprising that the outcome is also enormously variable, from individuals who will need institutional or one-on-one care all their lives to individuals who get married, find jobs, find a niche in the neurotypical, the non-autistic world. We know that there's no miracle cure for autism, but we know that expert, enlightened, education with understanding really works. And this isn't the sort of special treatment that parents have to pay thousands of pounds for or go to another part of the world for. These are miracles that are happening every day in our special schools and our special units all around the country. Education really makes a difference for autism. And perhaps most importantly, in the autism spectrum, everyone is different. So to quote Lorna Wing, once you've met one person with autism, you've met one person with autism. There's such a range of manifestations that many people believe it is the heterogeneity within autism that is the major stumbling block to advance in scientific understanding of this condition. Are we mixing apples and oranges when we take a sample and study a characteristic, either biological, genetic, behavioral, cognitive? We don't know. So I want to suggest, are we there yet? Not nearly. We've scarcely begun. And I want to discuss 5 pointers or signposts that I think might help us on our way. Let's begin with that triad of impairments, the defining triad of difficulties in social interaction, in communication, and in rigid and repetitive behavior. These 3 things are necessary for a diagnosis of autism, but how tightly bound are those 3 features? This has scarcely been assessed scientifically. And indeed, we can't answer this question by looking at diagnosed autistic populations. I want to tell you about some of our research that's attempted to answer the question. Should we think of autism as a monolith, or is a composite? So how closely bound are these features? We were able to investigate this question thanks to the MRC-funded Twins Early Development Study led by Robert Plomin at the SGDP at the IOP. And this is a population-based study of all the twins born in England and Wales from 1994 to 1996. It's representative of the general population, and these twins, thanks to their help and their parents' help, have been assessed at many ages from 2 onwards and are currently being assessed at age 16. We could ask the question, how strong is the correlation between characteristics on the triad? And we could ask this not just about impaired individuals, but about the whole continuum of ability. So we can ask not only how difficult does your son or daughter find it to make friends, but how easy do they find it? So we can measure social ability and social impairment. We can measure communication skill. How easy does your child find it to hold a natural two-way conversation? And we can look at the traits of being rigid and repetitive. How much would your son or daughter prefer things to stay just the same? And Angelica Ronald found that the correlation between individual differences in these different traits was only modest or moderate, around 0.4, 0.3, slightly different, slightly lower for girls than for boys. And so it certainly isn't the case that once you know somebody has a social impairment, you know that they're going to have a communication difficulty or going to be rigid and repetitive in their behavior and interests. And the same pattern turns out when you look at individuals who meet diagnostic criteria for autism, rather than looking across traits in the general population. And Katarina Dworzinski did this work, again, finding only moderate to modest phenotypic correlations between individual differences in the 3 areas of the triad. Because these are twins, we can ask about the influences of genes and environment on each of the traits and on the overlap between the traits. So because we have identical twins who share all their DNA and fraternal twins who share on average half their DNA, we can model what influence there is from genetics, from environment that makes children different, and from the environments that make children the same. And the findings from this work, again, led by Angelica Ronald, are that each of the features of the triad, social impairment or skill, communication impairment or skill, and rigid and repetitive behavior, each of these is highly heritable, with identical twins showing much more similarity than non-identical twins. But we can also ask the much more interesting question, are the same genetic influences operating on, say, social impairment and rigid and repetitive behavior? Are these parts of the triad linked at the genetic level or environmentally? And you can do that by comparing, for example, the degree of social impairment in twin 1 with the degree of repetitive and rigid behavior in twin 2. And these cross-twin, cross-trait correlations suggested that the genetic association, again, is only modest, so that more than half of the genetic influences on, for example, social impairments are independent of the genetic influences on rigid and repetitive behavior or interests. And surprisingly, the link between social impairments and communication impairments, either phenotypically or in terms of genetic overlap, was no stronger than the link between communication impairments and rigid and repetitive behavior. Now, this suggests then that somewhat different genetic factors are influencing the different parts of the triad. And this fits in very well with what we know from studying families where there's an individual diagnosed with autism. We've known for many years, thanks to the work of Patrick Bolton and others, that where there's an individual diagnosed with autism, there are often other relatives who show subclinical features of autism and typically show just part of the triad. So you might have an uncle who had a fantastic eye for detail, or a great aunt who found it very difficult to make social relationships. And so one can imagine these different components of autism coming together in the proband, the diagnosed child, but the different features segregating in different members of the family. It also fits with the notion that different associated features of autism should link differentially to different parts of the triad. So if autism is not a monolith but a composite, then some of the important associated features of autism may be differentially associated with, say, social impairment or with rigid and repetitive traits. And some of the really wonderful PhD students I've had the pleasure to supervise have investigated this question, among others, so that Fiona McEwen, for example, has shown that imitation as early as 2 years shows an association with later social impairments and somewhat with communication, but no association with restricted and repetitive behavior. Victoria Hallett showed that anxiety was most strongly connected to communication impairments and somewhat to rigid and repetitive traits, and surprisingly, rather little associated to individual differences in social impairment. And Pedro Vital investigated the link between special abilities and different elements of the triad, and I'm going to say something more about that later. If there are separate causes for the different parts of the triad that define autism, then one prediction would be that we should be able to find isolated symptoms. There should be people who just have social impairment, much like a person with autism, but don't have communication difficulties and don't have rigid and repetitive behavior. Again, you can't answer this question in clinic samples, but in the TED sample, because it's population-based, we could look at the natural rate of these different kinds of difficulties in isolation and in combination. And taking as impaired the top 5%, the worst 5% in terms of social skills, communication, or rigid and repetitive behavior, we examined how the overlap would cash out. And you can see here that around 3 or 4% have either social impairment, communication impairment, or rigid and repetitive behavior difficulties. And in combination, 10% of the children had difficulties in just one area of the triad. And these were difficulties at a level of severity comparable with that found in individuals diagnosed with autism, and from item analysis covering much the same kinds of quality of difficulty. You can also see that from chance alone, one would not predict as many individuals at the center of this composite. And so we see that, indeed, difficulties in these three areas do cluster together above chance, but still, the largest group by far are those who have isolated difficulties. In other words, autism fractionates. Now, I've talked about the behavioral level and the genetic level. What about the cognitive level? For many years, there's been a search to come up with a theory of autism that would explain the social and non-social aspects of autism in terms of a single underlying difficulty or deficit in how people with autism process the world around them. And I think that this search has been unsuccessful. It's very hard to derive the complex pattern of intact and impaired abilities, and indeed assets, in autism from a primary social difficulty or a primary non-social difficulty. Instead, there are a number of very promising and useful theories that help us to understand the different parts of the triad separately. So the notion that people with autism often lack or have a difference in theory of mind has been enormously helpful in explaining why people with autism have just the kind of social impairments they have and have just the kind of difficulty in understanding communication and in communicating with another mind. Problems in recognizing mental states doesn't wipe out things like attachment or wanting to connect with others, but it does put enormous barriers in the way of connecting with another mind through a real, meaningful, two-way friendship, for example. Problems in flexibility, the rigid and restricted behavior and interests, are well described by problems in executive functions, an umbrella term that covers problems in generating, planning, monitoring, the sorts of functions that the frontal lobe serves, the sort of functions you need, particularly in novel environments. And we know people with autism find most difficult coping with novelty and change. And on top of these, we need to understand why people with autism are often so good at certain things. And I think the notion of a special eye for detail, which I'll say more about in a moment, termed by Uta Frith weak coherence, has helped us to understand the assets and the uneven cognitive profile in autism. So each of these is necessary to understand different parts of autism. And indeed, in an autism population, we don't find that your performance on one of these areas, say theory of mind, will necessarily predict your performance on another, say executive function. So again, it may be best to think of autism as a composite of difficulties in theory of mind, central coherence, executive function, and maybe more. If this is the case, then we should be able to find groups, again, where just one of these areas is impaired. And indeed, the corollary of that is that we shouldn't think it's necessary that any of these core features be specific to autism. So in the past, there's been a tendency to reject theories of autism that are not unique to autism. For example, one might say, well, executive function can't be an important explanation or core element of autism because other people, other clinical groups have executive function problems and they don't have social difficulties. So how can executive function problems explain the pattern in autism? But if executive function problems are just one part of a recipe, an admixture that in interaction and together causes a special, qualitatively different outcome of autism, then we no longer need to say that core elements of autism need be unique or specific to autism. So that, for example, executive function difficulties may well overlap or be shared with individuals who have ADHD. And indeed, again, Angelica Ronald and Patrick Bolton and others have shown that there are large genetic overlaps between autism and ADHD. And Rhonda Booth and Rebecca Charlton and I have shown that in ADHD, you see a pattern where they don't share the eye for detail, that weak coherence or eye for detail, but they do show and share executive function difficulties. These are pictures from a very simple test where we asked children simply to draw a house, and you can see that the way that this young man with autism drew his house, beginning with the windows, illustrated nicely his eye for detail. And in the graph, you can see that this tendency to start with details was far more common among individuals with autism than among comparison individuals with ADHD. We also gave the same children a drawing task that involved planning. We asked them to draw a snowman and then to draw a snowman with teeth. If you're going to do that well, you need to plan ahead to allow enough space for the teeth. And we found in this task that both children with autism and children with ADHD showed planning difficulties. But importantly, the planning problems and the eye for detail, the weak coherence, didn't correlate in any of our groups. So these seem to be different features of autism, and the ADHD group and the autism group seem to share some elements of executive dysfunction. In the same way, we can suggest that other groups may share weak coherence or eye for detail. And the eating disorders team at the Institute of Psychiatry have been exploring this idea in individuals with anorexia and other eating disorders, and have found that people with anorexia are very good at some of the detail-focused tasks that people with autism excel at. And this has led them to develop new sorts of interventions. And we can also suggest there'll be groups who share theory of mind difficulties without sharing other parts of the triad. And again, Rhonda Booth, with working very much with Corpel, the Parents Association, has been working with children and adults who are born without a corpus callosum, the major band of fibers that connect the right and left hemispheres. And these individuals with agenesis of the corpus callosum often show a sort of mind blindness akin to autism, but don't seem to show any detail focus. So the different parts of the triad can appear in isolation, also at the cognitive level. So the implications of this fractionated triad approach are that we should abandon the search for the causes of autism as a monolith, the genes for autism, and instead look for contributors to parts of the triad, the genes that contribute to individual differences in social skill and difficulty, for example. No single factor, either genetic, neural, or cognitive, need be specific to ASD, and overlap with other diagnoses is predicted. Indeed, comorbidity should be the rule. Heterogeneity is expected at every level, because if the three parts of the triad differ independently, then we're going to get every possible combination. And single deficits are common and deserve study. Who knows what diagnoses, if any, of these children get? Who knows what needs they might have? Okay, I'm on to my second signpost. My second signpost is to suggest that autism is not just a deficit, but a different cognitive style. So part of understanding autism will be understanding the way that people see the world differently rather than deficiently. And I got excited about this aspect of autism, this theory begun by Uta Frith, when Lorna Wing told me an anecdote about testing a young man with autism, and she asked him to name the various things they were going to use in the assessment. And he named the toy doll and bed and quilt and so on. And she pointed to the little toy pillow and asked him, "What's this?" He said, "It's a piece of ravioli." And the nice thing about this anecdote for me, the exciting thing, was that Lorna said, when she looked at it again, it did look exactly like a piece of ravioli. So it wasn't that the boy was making a mistaken judgment or perception. Rather, he was able to see that element in isolation, uninfluenced by the context. And the National Autistic Society a few years ago had a poster that I think sums this up quite nicely. I know that the text is far too small to read, but the poster says, when a person with autism walks into a room, the first thing they see is a pillow with a coffee stain shaped like Africa, a train ticket sticking out of a magazine, 25 floorboards, a remote control, a paperclip on the mantelpiece, a marble under the chair, a crack in the ceiling, 12 grapes in a bowl, and it goes on. And then it says at the bottom, so it's hardly surprising that they ignore you completely. The important thing about the notion of detail focus in autism, the ability to focus on aspects of the environment unaffected by context, which Uta Frith referred to as weak coherence, the important thing about her notion was that it could explain in one go what people with autism found difficult and what people with autism found very, very easy. And this is one of the tasks that people with autism find very easy, the embedded figures task, where you have to find the simple figure within the compound figure. And of course, the simple figure is camouflaged in the gestalt of the whole using color and other things. So we find it hard to spot the figure because we see the whole as a whole. People with autism who may be able to see the whole in terms of its constituent parts often excel at this task. Of course, having a fantastic eye for detail causes problems too, because we know that individuals with autism are resistant to change or insistent on sameness, in Kanner's words. But we're all insistent on sameness in some sense. If every time you went to brush your teeth, your partner had hidden your toothbrush somewhere else around the house, you wouldn't find that very amusing. We like some things to stay the same. It's just that people with autism like things to stay the same at a level of detail that appears to us to be tiny or trivial, but maybe to them enormous. If you happen to be lucky enough to be sitting next to somebody with autism in the audience, they can point out the differences. I designed it, but I can't remember where they are. Now, we've suggested that as well as causing difficulties, the eye for detail, or weak coherence, is also the major clue to understanding the puzzling association between autism and talent. So we know, thanks to the work by Patricia Howlin and others, that perhaps as many as 30% of individuals on the autism spectrum have a special skill, usually in maths or music, art or memory. Understanding why that association should be so high in this group, so much higher than in any other group studied, has been a major puzzle. But we believe that this has strongly to do with the eye for detail, which gives you a kickstart in music, in art, in maths, or at least in calculation, and certainly in memory. And Pedro Vital, again studying the TED sample, asked parents to tell us if their children were unusually good at maths, music, memory, or art, and also to tell us how their child fared in terms of social impairment or skill, communication, and rigid and repetitive traits. And he found a strong association between parent-reported talent, those children who were said to be even better than children much older than them at music, maths, art, or memory, and parent-reported rigid and repetitive traits, and particularly the eye for detail, noticing and remembering things that other people miss. And most interestingly, again, because these are twins, Pedro was able to show that there's a strong genetic association between parent-reported talent and these non-social autistic-like traits, so that some of the genes that are contributing for autism are the genes that are contributing to talent. Stephanie Leitz, who's just finished her PhD with me, has also been looking at how this eye for detail may help us to understand one of the least well-researched areas of autism, sensory difficulties. Parents and professionals and individuals with autism have for many years been telling us that this is one of the most distressing and difficult elements of autism, that people find some sensory stimuli extremely distressing, children who cover their ears at sounds that would seem mild or hardly noticeable to the rest of us, but also sensory fascinations that lead to sensation-seeking and repetitive behavior. These sensory abnormalities have been largely neglected up until recently in terms of research, but we've suggested that they may reflect in part a failure to use context. And that's because we know from typical development that expectations modulate experienced sensations. If in a context we are able to predict the next stimulus, we experience that stimulus as being less intense and, depending on the context, less unpleasant. So Steph has designed a very nice task where she gives a very simple story context and then allows the child with autism to experience a sensation, so that, for example, she might tell the child, Sarah was getting ready for school, she reached in the closet for her coat. And then the child gets to put their hand inside a box which is opaque, they can't see inside. And the child might either feel cloth, which would be congruent with the context they've been given, or they might feel dry leaves that would be completely incongruent with their expectations. And in typically developing children, the presence of congruent or incongruent or no context makes a real difference to how long they choose to explore the stimulus or how much they say that they like it. But in individuals with autism, there's far less context modulation of experience. And Steph has made a real effort to make this task really applicable to individuals who are low functioning, again, a highly neglected area of the autism spectrum, so that by looking simply at how long the child chooses to experience either the touch, sound, olfaction, or vision, we can get some measure of what difference context is making for children who may have no speech, for example. So people with autism appear to be less affected by context, and this may be just the beginning of a clue to understanding sensory difficulties in autism. My third signpost is about taking development seriously. And in particular, I want to talk here about the developmental gatekeeper that is reading other people's minds. So theory of mind, or mentalizing, refers to the everyday ability to recognize and represent what might be in somebody else's mind, what they might be thinking, believing, wanting, pretending, and so on. And we see from very early in neurotypical development that children are shaping each other's learning context and having their learning shaped by others because we are drawn magnetically to other people's actions. You can't walk down the street and see people staring up, pointing up at something without looking. We don't have a choice as neurotypicals. But for the young child with autism, the learning environment from very early on is completely different because people with autism don't have obligatory attention to other people. They don't find others necessarily more interesting than objects. And so you can see here on one side the neurotypical child keen to see what his mother or father thinks of his activities, and the other child busy about what he finds interesting. And so we've been exploring the downstream effects of mind blindness, or difficulties in theory of mind. And originally with Uta Frith, and later with Antonia San Jose Caceres, we've been looking at the impact that mind blindness has on measured IQ. So we've found that people with autism who have very low measured IQ, and that's, of course, a large section of the autism spectrum, even though autism is quite compatible with extremely high IQ. People who have low measured IQ are able to do extremely well on simple inspection time tasks that in ordinary people correlate highly with IQ. So in these tasks, you have to make a simple same, different, or bigger, smaller judgment, but at increasingly rapid presentation speeds. And individuals with autism are able to make those simple judgments at extremely rapid presentations. which in an ordinary child would go with having high measured IQ, but in these children, there seems to be a major discrepancy. And we've suggested that this discrepancy comes about because the children with autism are unable to cash in that learning potential because so much learning in our world depends on learning through other people, socially mediated learning. We've also explored how mind blindness affects language acquisition and the kinds of mistakes that happen when you're trying to learn language without paying attention to what other people are interested in. And with Dave Williams, we've explored how reading other people's minds and reading your own mind may be intimately connected. So we found that individuals on the autism spectrum have difficulty interrogating their own mental states, knowing, for example, whether they definitely know something or are merely guessing, or tracking what they intended to do, or tracking what they used to think. And these difficulties in understanding own mind may be relevant to both to understanding emotional difficulties in autism and to understanding which treatments will work for, say, anxiety or social anxiety, and which treatments are going to be a dead end. I want to say that social insight has costs, so our obligatory attention to others is not without its own costs. And Temple Grandin, who many of you may know is a very brilliant woman with autism, who writes about autism but also writes in many other areas of expertise. But she likes to say that if it had been left to the neurotypicals, the people without autism, we'd still all be sitting around campfires in furs and living in caves, because we'd be so busy gossiping and so fascinated by what each other had to say that we never get beyond that. And it took somebody on the autism spectrum to get bored of the gossip and go off and invent the wheel. And clearly, this obligatory social attention means that we all become, whether we want to or not, members of a herd. And of course, herd behavior and conformity can be very dangerous. It's also the case that adults with autism spectrum disorders who become better at mind reading later in life are actually at greater risk of anxiety and depression than those who remain more mind blind. So social insight has costs. Part of thinking developmentally, part of this signpost, is a signpost towards autism in old age. This photograph is of Donald T., who was Kanner's case number 1 in his original description of autism in 1943. And there's a wonderful article about Donald, aged 77, in The Atlantic magazine, which really conveys what an extremely rich and happy life he has led and continues to lead. And he travels the world, and he plays golf, and he's very accepted in his community. But of course, many other people aging with autism have much harder lives. And most shockingly of all, we know practically nothing about autism in old age. We don't know whether living your whole lifetime under the stress and anxiety that almost everybody with autism experiences leads to major health problems in later life. We don't know whether lifelong learning, the potential for learning, is extended in autism. We don't know whether having had to compensate and develop strategies throughout your life to make up for core difficulties in those triad areas actually means that people with autism are better able to continue to compensate in old age. We don't know any of these things, but this is surely a signpost we need to follow. Signpost number 3 is focusing on women with autism spectrum disorder. No, number 4, I think. So here you can see Wendy Lawson, fantastic author with autism, Temple Grandin, Ros Blackburn, wonderful young woman with autism. We know hardly anything about women with autism because the sex ratio of diagnosed individuals with autism is around at least 2 to 1 male to female, and at the high IQ end, maybe more like 5 to 1, even higher. We don't know whether this reflects bad diagnosis, that we haven't got the criteria right to recognize in women. I'm sure there is an imbalance. There's an imbalance in almost all developmental disorders to affect males more than females. But are the ratios really as high out there in the population as they are in the clinic? Again, we've been lucky to be able to look at the population sample of TEDS, to begin to try and answer this question. And so what one can do in a population sample that one can't do in a clinic sample is to ask, how do women and men who have received a diagnosis of an autism spectrum disorder differ from other women who have extremely high, similarly high autistic traits, but haven't actually been diagnosed? So Katerina Dworzinski has done this work that is in progress and not yet published, where we've looked at features of those diagnosed and non-diagnosed but high autistic traits, girls and boys, around age 12. And what we find is that, as is typically reported in research comparing boys and girls with autism, there are more girls, diagnosed girls, than diagnosed boys who have very low IQ. So this is what's typically reported, that girls are more hard hit by autism than boys, but less often hit. But if you look at the individuals who have similarly high autistic traits but haven't been diagnosed, you find that this association with low IQ no longer holds. So interestingly, in girls, but not in boys, diagnosed girls are more often low IQ than non-diagnosed high-trait girls. In boys, the difference is much slimmer. We also looked at other kinds of problems based on teacher-rated behavior from the SDQ, so things like anxiety, but also ADHD or conduct difficulties. And we found again that diagnosed girls had many more behavior problems than non-diagnosed high autistic trait girls, but this difference didn't exist for boys. So again, the diagnosed girls had more behavior problems than the diagnosed boys, fitting this typical pattern of saying autism is more severe when it manages to break through in women. But when you look at non-diagnosed but equally highly autistic in trait women and men, you don't find that difference. So this suggests to us that in order to get a diagnosis, if you're a girl, you must have, or it helps to have, intellectual impairments or other behavioral problems, and that we more rarely give this diagnosis to women, even though they exist out there, women who don't have intellectual difficulties or other behavioral problems. Now, this could, on the one hand, suggest that we're getting diagnosis wrong, that our diagnostic criteria are biased towards a stereotype of the male with autism, and that we're not good at recognizing women with autism in the clinic. But it could also mean that women with autism are genuinely compensating better. So despite their high autistic traits, the non-diagnosed women are non-diagnosed for good reason, that they actually are managing to compensate rather better. I think looking at the sample at age 12 is too soon to answer that question. We need to look at adult samples, for example, to know whether, despite not receiving diagnosis, there's actually significant suffering in those individuals, those women with high traits of autism. So my final point, my final signpost, is a plea, really, that we need to understand how people with autism see and understand and process the world in order to say that we understand what autism is. There is a tendency, perhaps especially in the States, to believe that understanding autism merely means understanding what causes autism. And that means understanding the genes or understanding the neurobiological pathways. Without doubt, that's important. But I would like to say that that isn't everything. That won't constitute a true understanding of autism any more than Down syndrome is simply understood by understanding the trisomy and the genetic basis. I think we need cognitive theories even to get to that understanding of the biological etiology. Because, for example, you can't do functional brain imaging unless you have a cognitive theory that will tell you what you should do when the person is lying in the scanner. What should you show them to look at the brain activity associated with particular tasks? What tasks should you subtract from that particular task? You can't identify which family members you should consider affected when you're doing your genetic pedigrees to find out how genes associate with autism. unless you have a proper cognitive theory of what autism is. So if you simply look for individuals who have autism or have mild autism, you'll miss the individual who maybe has an extreme gift, who has a fantastic memory, who should be relevant to be marked on your pedigree. And your cognitive theory is going to make a huge difference to things like making making animal models that will inform your search for the neural basis of autism. Let me give you an example. We know that people with autism have difficulties in face processing and face recognition. If you want to look at whether your mouse model of a particular gene, your knockout mouse, is showing a relevant kind of difficulty, the answer and how you test it is going to depend on your theory, your cognitive theory, of why people with autism have face processing difficulties. If on the one hand you think people with autism have face processing difficulties as a result of social impairment that makes them look less often at faces and therefore not become face experts as the rest of us become, then it will be appropriate for you to study that in the knockout mouse by looking at how mice greet and recognize one another, which is primarily through scent and olfaction. If, on the other hand, your theory of why people with autism don't recognize faces well is to do with an eye for detail and a difference between local and global processing, then using olfaction is going to be a waste of time because olfaction can't measure that tendency to process details. But instead, there are simple non-social visual tasks that you can give to animals that allow them to choose and show you whether they're paying attention to parts or to holes within a visual array. And that would be the way you'd want to look at cognitive processes relevant to autism. And of course, over and above all this, knowing which genes are affected in autism isn't going to be helpful today or tomorrow to the teacher or the parent who wants to understand the young person with autism that they work with or live with or love. So cognitive theories of autism are relevant in everyday life. They've been relevant to things like early diagnosis, and they're relevant simply to understanding the great puzzle that a person with autism can be to neurotypicals and helping us to be less puzzling to people with autism. So just to give you maybe one example for the sake of time, we tend to think that because people with autism are very visual, often very much happier with visual signs than with spoken language, that signs will be transparent. But of course, the signs that neurotypicals that we design require mind reading. And that's why a young man I know with autism has often been in danger on the roads because as he goes to cross the road, starting off with a green man, when the green man changes to red, he stops dead wherever he is, even if he's in the middle of the road, because that's what the sign has told him to do. Of course, neurotypicals understand the communicative intention, but that requires mind reading. And similarly, the older woman with autism who won't use public lavatories that have the typical sign for women because she never wears a dress or skirt and always wears trousers. So this sign for her isn't relevant. And a very nice example that I saw on a website from a mother, Amelia Starr, where she describes her son with autism getting increasingly frustrated and upset as he tries to operate this machine that you see here by pressing that very worn-out corner at the end of the arrow rather than the red lever at the bottom that the arrow is meant to indicate in order to work the machine. So in order to make the world useful, accessible, educational, helpful for people with autism, we have to understand how they see the world, not merely how their brains are configured or how their DNA looks. So my 5 pointers or signposts: when will we understand autism spectrum disorders? Well, we'll understand autism spectrum disorders a little better when we reconceptualize autism as a composite, when we understand that ASD is in part a different cognitive style, when we think about developmental effects lifelong until the end of life, when we know much more about women with ASD, and when we understand how people with autism see the world. There are so many people that I could thank, and I should thank most of all the people with autism and their families, and the other individuals who've taken part in our research without whom we couldn't do any work. The schools and teachers who've welcomed us, again, too many to thank in person, but we're so grateful for your help, and we learn so much from you. I've had so many wonderful PhD students, and they really are a joy. You've heard about some of their work, and I couldn't mention all of them, again, because of time. I've had the most inspiring colleagues and the best mentor and colleague and friend in Uta Frith, and wonderful colleagues at the SGDP. We've been lucky to have funding from a number of different sources. I want to thank the Royal Society, of course, and thank you for listening. And because it is the Rosalind Franklin Lecture, and it is about women, maybe I can also say something in thanks that reflects what it is to be a woman and a scientist. So I have to thank my parents, who make it possible to juggle family and work, and make sure that I drop as few balls as possible in that juggling act. I have to thank Daniel, my partner, my better half, who makes everything possible, and thank my children, Poppy, Joe, and Sam. Even though they won't be watching this anymore, they'll have turned over and they'll be watching SpongeBob. So thank you very much.
We have time for a few questions from the audience. Perhaps I can start the ball rolling, Francesca. So you have these three elements of autism: the communication, the social impairment, the rigidity. And you've shown beautifully how they can be fractionated, separate. Do they have separate brain pathologies or mechanisms? Can you say something about that?
Yes, so again, we know perhaps most about the brain pathways involved in theory of mind because we can do really good functional imaging studies in which we elicit thoughts about other people's minds. And there we have a network of regions, including the medial frontal cortex and the temporal poles, the amygdala, and STS. And we have a different sort of network involved in different sorts of executive function, so it depends which part you'd be interested in. The eye for detail has been far less examined, but may relate to the differences in functional connectivity that have been suggested to be probably present throughout the brain in autism.
Thank you. Please, yes, there. Thank you. There is a microphone, and can you please use it? And perhaps you could state your name as well.
Thanks very much. Very inspiring talk. My name is George Crowther. I'm a psychologist. You quite rightly pointed to the positive value of education in relation to ASD, but I would like to ask what your thoughts are about the politics of ASD and the special educational needs agenda.
I think you probably have to be more specific, but maybe that's a long specifier.
Well, I think one of the issue basically for me is that in relation to the diagnosis, whether it's made by a community paediatrician and his or her team, or whether it's made by a child and adolescent psychiatrist and his or her team, at the end of the day, who pays for it? Education pays for it. They pick up the tab all the time. And that's why I think there needs to be a serious debate about ASD and the diagnosis and who funds it. That's what I mean by the politics.
Okay. No, this is obviously very, very relevant, and particularly relevant maybe for adults with autism, where they typically fall between the stores of mental health and disability, intellectual disability. And what you're saying is clearly true, because the rates of diagnosed autism around the country are very different, and some educational authorities barely recognise the concept. I think it's a huge debate. I don't think I can answer it, but I certainly acknowledge it, and maybe that's the starting point.
There was another question there, yes, in front there, and then one at the back afterwards.
Hi, Robin Whitty, London South Bank University. I'd like to know if there's an interaction between the study of ASD and dementia, because all parts of the triad display very much in some people with dementia.
It's very interesting. That I don't believe that research is going on at the moment, but hopefully there's increasing interest in autism in old age. And we simply don't know whether people with autism show dementia earlier, whether they show dementia differently. We don't know. There is some investigation of theory of mind in some of these other areas, like frontotemporal dementia. I don't know of work on detail focus specifically in dementia. There's work on local global processing and aging. We're trying to do some work in that area and pull those different strands together, but I don't think that that's been looked at so far, but it's very interesting.
At the back there, yes, please.
So I'm a teacher. Any comments on the sexual disparity and Simon Baron-Cohen's work, and is it testosterone, brain development? Any comments on that in terms of giving some clues to what's going on?
Well, I've suggested that we maybe need to think again about the rates in women based on our studies, not in clinics, but in the general population. So I think that would be important. I don't think that autism can be understood as simply as thinking about a male or female brain. For one thing, I think implicit in Simon's theory is the idea that the male brain involves being poor at mind reading, also poor at other things like empathizing, which actually isn't true in autism. People with autism do care, even though they're not good at knowing what somebody else is thinking. But it says that you're going to be bad at mind reading and you're going to be good at systemizing, which is maybe related to weak coherence. In actual fact, we find these things, two things are separate. They're not highly related. Again, the testosterone theory, although very interesting, predicts that these two things are highly correlated because he suggests that fetal testosterone relates to later interest in non-social things and repetitive behavior, and also relates to poor social and communication skills. We find these things aren't tied together. So I think searching for a single cause is a mistake, but it's certainly interesting work.
Hi, I'm Abby. I'm applying for university. I was wondering, with regards to what you were saying about different areas of the triad appearing in non-autistic spectrum disorder individuals, what do you think of the theories that might suggest that everyone is on the autistic spectrum in some way?
That's a good question. So it's often said that everyone's a bit autistic. I think it depends at what level of analysis one's talking. So behaviorally, you can certainly put everyone on a smooth continuum. And it's very interesting that looking in a general population sample, you don't get a sort of bimodal distribution with all the neurotypicals here and then a blip where all the people with autism lie. It is indeed a smooth continuum. But it's a smooth continuum in 3 dimensions, one of them being social, one communication, and one rigid and repetitive. And all of that space is filled. But I would say at other levels of analysis, the answer may be different. So at the cognitive level, I do think that most people with autism experience, at least for some part of their development, mind blindness. They really find it difficult to represent other minds. I don't think that's what underlies individual differences in social skill in neurotypicals. I think that's much more to do with other things like social anxiety, temperament, personality, and so on, all of which are relevant in autism too. So I think mind blindness probably is a discontinuous trait cognitively. Weak coherence, detail focus, I'd be happy to put that on a continuum. Executive function probably depends which executive function you're talking about, but many of these continue to develop and show individual differences well into adulthood. At the neurological level, at the genetic level, who knows? So I think the answer to are we all a bit autistic really depends, are you talking behaviorally, cognitively, biologically, either neural or genetic or environmental?
We will take 2 more questions, one there and one there. That's it. Thank you.
David Arms, Imperial College. Is it possible that people with, say, schizophrenia who've had autism in the past, that the voices, which are apparently so-called voices in their head, are a way of compensating for having poor social skills, poor communication skills? And could this way of thinking, when it's not seen as pathological, be important for the understanding of autism?
That's very interesting. What an interesting question. So I think very little is known about individuals who have autism developmentally and develop psychosis on top of that, develop schizophrenia later in life. There's been a lot of misdiagnosis in the past where people haven't taken sufficient account of developmental history and have asked an adult who actually has autism, do you hear voices when there's no one there? And they say yes, and it turns out they mean when the radio's on. But the real cases, which do indeed occur, where you have autism and then you have psychosis in later life, I don't think they've been sufficiently studied. It's a very interesting possibility that some of that hearing of voices is to do with not recognizing your own mental states as your own, which Chris Frith has explored in schizophrenia. And indeed, it's a very interesting possibility that they could be used in an adaptive way. I think that just remains to be studied. It's a very interesting idea.
I'm James Shaftesbury. I'm not in the field. I'm a reader here at the library. Many of the traits in the two triads are highly adaptive. I want to cite people like Paul Dirac, Newton, Wittgenstein, and particularly Cavendish. And those traits being so adaptive, when they are taken in isolation, make a perfect example of why these conditions survive in the gene pool. However, with pleiotropy, we have so many different mixes, and sometimes those combinations can be, normally are detrimental. It's the exception that's not detrimental. The traits seem to be predominantly on the Y chromosome. It's a very male thing, and most of those traits in the triads are generally associated with male characteristics. And it strikes me that we shouldn't really be looking for a cause, because we've already established that it's very genetic. It reminds me of something Dean Hamer, who's famous for postulating genes or a gene for homosexuality, often cites the problem that why would a gene be prevalent for homosexuality when they've got no chance of reproducing? And the answer he gives is because the genes in combination with other genes, hence pleiotropically again, or when those genes are in relatives who don't have, this is the reverse, who don't have maybe two recessives, which would in the wrong case cause homosexuality, rather in the same way as sickle cell is a problem. It's an advantage against malaria, but it's a problem if you have two recessives.
Yes. So what is the question?
The question is, do you not think that there's as little chance of dealing with this as there is, say, dealing with, as they used to say, dealing with the problems of homosexuality? It's in the genes. It's most unlikely you'll find a cause because it's in the genes. The only remedy for this kind of thing is to eliminate those genes, and that's not possible in human beings.
I think what I've tried to argue for is that because the different parts of autism are fractionable, we could look to intervene on those parts that are deleterious, which is the social impairment and the communication impairment, without necessarily interfering with the eye for detail, for example. And I'm glad that you mentioned Wittgenstein, because his picture was up there, and I get rather upset about all the Asperger and autism spotting that happens with everybody who's talented in any way at all. And again, what I would suggest that it's not that these people are a bit autistic, but that they share a cognitive style with individuals with autism. But as you say, when that cognitive style arises in combination with other features, then the outcome can be very different. So thank you for your question.
It comes to make the award. So first of all, I'd like to make a vote of thanks to Francesca Happé for this wonderful talk. It's fascinating, interesting, stimulating, on a topic of really general interest, which I think was borne out by the comments from the audience. I'd like to congratulate you on this prestigious award on behalf of the Royal Society. I give you a scroll here and also a medal.
Thank you.
Thank you very much.